In this video, we'll be tackling task 18, and we're finally at the point where we can put together our probabilistic result sheet. So this sheet is now visible and I have it open on the right of my screen. And in step 18.1, we're going to put together the summary results table. So this looks very similar to the one that we put together for the deterministic analysis back in part 1. One important difference is that we are looking at expected costs, expected incremental QALYs, and so on, because we're using the average across all of those Monte Carlo simulations. So because there is uncertainty in the model, we don't know exactly what the costs and the QALYs are and the net benefit and the ISA. We don't know exactly what those are, but we have an expectation across those 1,000 Monte Carlo simulations. So just to be clear, when we have a probabilistic analysis, we need to talk about expected costs, expected QALYs, expected net monetary benefit. Okay, so we need to start filling in this table. And you can see it says in D21, enter a formula that pulls in the expected total aggregated discounted costs for treatment A from cell BM44. So if you go back to the discounting sheet just very quickly, BM44 was here. And remember, we assigned a name to that. So R underscore mean underscore costs underscore A. And I mentioned at the time when we saw that cell that this is really important. We're going to include this on our probabilistic result sheet. So you can either just click on that cell, press equals and then navigate to that sheet and click on that cell, or we can just type in R underscore mean. And you can see there's a list here. So R underscore mean costs A, and I'll press enter. And then the one below it is similar, but for B. And R underscore mean costs B. Okay, just like before, we have these NAs because we don't calculate incremental costs or QALYs or net monetary benefit for treatment A because it's the less expensive treatment. If you, excuse me, if you do delete these, make sure you put them back in. Make sure it says, and you've got the / between the N and the A. That's how it needs to be for it to be marked as correct. Okay, so what is the expected incremental cost? There's a couple of ways you could do this. You could pull it in from the sheet, from the incremental output sheet. So we'll do that for this first one. So equals R, and then it's mean incremental cost. So it's this one here. Pulls it in from cell BM33 on the incremental output sheet. So that's one way of doing it. You could also, for these particular calculations, just calculate it from these two numbers. Okay. So for the purpose of this table, you can just do calculations within the table. The reason that we have all of those sheets is because we need the pair cycle costs and QALYs and incremental costs and QALYs and the incremental net monetary benefit. We need all of that for some of the figures that we're plotting on this sheet. But for the purpose of the summary of the results, that's just about the means, yes, you can do calculations just within this sheet. So what about the expected QALYs? So we're going to say equals R mean, and it is the QALYs for A. And then we've got the same thing, but for B. So let's do the other approach now. Let's just calculate the expected incremental QALYs just based on these two numbers. So equals this one minus this one. And you should find that that's exactly the same as if you just pulled it in from the incremental output sheet. Okay, now the expected net monetary benefit, and recall that this is something that is distinct from incremental net monetary benefit. We actually don't have a sheet where this has been calculated because it's very, very easy to just calculate within this table. So that just equals the QALYs for the treatment in question, I should say the expected QALYs in this case, multiplied by the S threshold, the cost effectiveness threshold, and then you need to subtract the expected costs. So this one here. Okay, and then we can just take that, copy it, and paste it in here. Okay, and then for the incremental, for the expected incremental net monetary benefit, again, you could just calculate it by subtracting this from this. Or we could just put in R underscore mean, and you can see the incremental net monetary benefit there. That pulls it in directly from the incremental net monetary benefit sheet. Oops, didn't mean to click off there. Okay, and then the final cell that we need to do here is the ISA. Okay, so that's going to be the expected incremental costs divided by the expected incremental QALYs. And just something here about language, we don't call this the expected ISA. And we also don't calculate the ISA for every iteration and then average over that, because that would give us the wrong result. We don't do that. There is only one ISA. And that's why we don't call it the expected ISA, because it's not that we've got lots of ISAs and we're averaging over them. There is one ISA, and in a probabilistic analysis, that is calculated by taking the expected incremental costs and divided by the expected incremental QALYs. So that's just why we don't call it the expected ISA. There is only one of them, and it's incorrect to calculate the ISA for every iteration and then average over them. That's not how ratios work. You will get the wrong answer if you do that. Okay, step 18.2 is to plot a scatter plot on the incremental cost effectiveness plane. So this is very much like the figure that we had in part 1, but instead of there just being one point on this plane for figure B, for treatment B, I should say, we have 1,000 points, one for each of the iterations. So it gives us a visual summary of the uncertainty in this economic evaluation. And what we need to do is put the threshold line on this. So treatment B has been done for you because there's so many points, and that's already been done for you. But the threshold line needs plotting. And again, we need to put in two different combinations of incremental costs and QALYs, and a line will be plotted through them. And so here we'll do something slightly different. It says in the instructions, your X values will be the incremental QALYs in iterations 1 and 2. Okay, so the incremental QALYs in iterations 1 and 2 on the probabilistic sheet. Okay, so equals, sorry, 1 second. So in the incremental output sheet, so equals, then we just need to go back to the incremental output sheet. And where are the incremental QALYs? They're over here, and this is the one for iteration 1. And the next one, oh, that says incorrect. What did I do wrong? These can be found in cells DX39 and DX38 and DX39. Okay, and they're going to be the X values, which are the incremental QALYs. BO, what did I do wrong here? So we'll go back to incremental outputs. I went with cycle 1. That's what I did wrong. I need to go for the total. Okay, so very easy to make a mistake. And this automated marking system is very useful, even for me. Okay, so let's do the same now for iteration 2. We need to go to the total. I believe it's this one here. So DX39. And then it says in the instructions, the corresponding Y value for each X value may be calculated by multiplying the X value by the cost effectiveness threshold. Okay, so we're just going to say equals this multiplied by S threshold. And the last thing I'll say about this particular step is, we're using these these QALYs for iteration 1 and iteration 2. We really don't have to, right? You could use an incremental QALY of 0 and 1. You could just do that. So the purpose of this task is just to show that, you can use almost any QALY value you want, as long as you then multiply by the threshold to get the incremental costs. There we go. So we have these two different points, and we now have a line across our plane. And if you recall, with a willingness to pay $50,000 per QALY, which is what this threshold is currently representing, most of the iterations found that treatment B is not cost effective. And they're plotted above the line. That's what we can see. You can also see just a handful of iterations which are below that line. And those are those handful of iterations in which treatment B is cost effective. Okay. The next thing, calculate the proportion of iterations above and below the threshold. Okay, so how would we go about doing that? So first of all, we need to pull in the threshold value. So equals S threshold. So at a threshold of 50,000, how many points are going to be above the threshold? So that is just the from the SEAC information. So we just go R SEAC A. So the points above the threshold line, those are the ones where treatment B is not cost effective and therefore treatment A is cost effective. So just R SEAC A. And then for the next one, you could just do 1 minus this, or you could put in R SEAC B. Okay, yeah, it's happy with that. So at a $50,000 per quali threshold, almost all of these points are above the threshold line, and it's very unlikely that treatment B is cost effective. Okay, it says, oh, there's a few questions here, right? So you can now perform some basic sensitivity analysis on the model. Go to the settings sheet and set the threshold to 100,000. So I'll do that on the left. And take a good look at the screen on the right, see what happens as soon as I make this 100,000. We'll need to recalculate quickly, and then notice how the threshold now cuts through the middle of these. So 45% are above and 55% are below. You'll notice that the ISA has not changed. Right, the incremental costs and qualies have not changed, but the expected net benefit has changed because that depends on the threshold. And the expected incremental net monetary benefit is now positive, indicating that on average, it appears that treatment B is cost effective. If I go back to the instructions, so in terms of has the summary table, yes, it has changed. The expected net benefit has changed, but the ISA has not. Has the proportion of markers above or below the threshold line changed? Yes. And you'd interpret this as treatment B having a much higher probability of being cost effective now. And then take a look at the incremental net monetary benefit probability map. So this shows the cumulative, I'm just going to move back over here. This is the cumulative incremental net monetary benefit. And so you can see that it does eventually break even. So after, was it about 52 cycles, if I recall from the earlier task, this does break even at a threshold of $100,000 per quali. And what these contour lines, the highest ones show, is that there is a small chance, I believe that's the 5% line or the 10% line, there is a small chance that treatment B will break even much earlier at 20 cycles. And then I believe this bottom line is showing the, let's count how many lines there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I believe these are the deciles. So there is a, there's a 10% chance that it will just not break even at all, right? So these contour lines show the deciles of the distribution of the incremental net monetary benefit at different cycles. We would expect it to break even after about 50 cycles, but there's a chance that we break even much sooner, and we can read that probability off this map. But there's also a chance that we don't break even at all during the cycle, during the time horizon in question, during the 60 cycles. Okay, so let's tick this box when we're ready to continue. Okay, the next one is about a shorter time horizon, and it's asking us to change the time horizon to 4 years, which is 48 cycles. So we'll go to the settings sheet and change this to 48. And you can see on the right these things changing in real time. So we'll go back to the instruction sheet. Has the ISA changed? Well, let's take a look. Yes, the ISA is now 102,816. So that ISA has changed. If so, why might this update following a change in the time horizon, but not following a change in the cost effectiveness threshold? So we have to remember that the threshold is not a consideration when we are estimating costs and qualies, calculating expected costs, qualies, incremental costs, qualies. The threshold doesn't go into any of those calculations, so it also doesn't go into the ISA. You compare the ISA to the threshold, but the ISA itself is not impacted by the choice of threshold. However, the net benefit estimates are impacted by the threshold. So the net benefit will change when the threshold changes, but not the ISA. However, how you interpret the ISA does change, of course. You have a different threshold. Has the probability map updated following the change in time horizon? Well, no, it hasn't. This is exactly the same as it was before. And the reason being, the probability map actually incorporates the time horizon within it, right? So the probability map is showing the cumulative incremental net monetary benefit for all possible time horizons. So the fact that we have lowered our time horizon to 48 cycles rather than 60 makes no difference to this map. And you can see that at 48 cycles, you can see the incremental net monetary benefit would be slightly negative, the expected incremental net monetary benefit, which corresponds to what we have in the summary table here. Is treatment B still considered cost effective in this probabilistic analysis? And if not, why not? Well, our threshold is $100,000 per quali, and the ISA is slightly higher than that. So treatment B is not cost effective. And so that's one way of considering this. The other way is to look at the expected incremental net monetary benefit. That's negative. So by reducing, so first of all, we raised the threshold to 100,000, and that made treatment B cost effective when it wasn't before. But then we shortened the time horizon, and that made treatment B not cost effective again. Okay, but only just, right? The ISA is only just above 100,000. Finally, take a look at your deterministic results. Does treatment B appear cost effective at this time horizon? Okay. And you can see that, yes, it does appear cost effective. The ISA is below 100,000. Yeah, this is, there is a difference, right, between what you would get in the deterministic analysis and what you get in the probabilistic analysis. And the reason that you would get a difference in the ISA between the probabilistic and the deterministic is because there are nonlinearities in the model. So we would not expect to get the same ISA. And so which set of results should take precedence? Well, it is the probabilistic results that should take precedence. Okay, so please tick the checkbox to the right when you're ready to start the next step. Okay, and we're now on to 18.6, which asks us to return the settings to the default values. So we'll go to settings, we'll make this 60, we'll make this 50,000. Okay, and that brings us to the end of task 18, and I will see you in the next video for task 19.